I haven't proved this, but you're going to see soon enough that anytime you get an equation of the form ax plus by plus cz, a, b, and c are constants, equals d is a constant. Anytime you get an equation of this form, notice x, y, and z are all brought to the first power. Anytime you get an equation of this form, you've got yourself a plane. And I'm actually going to prove that to you in a future section. But there's no reason why we can't graph a part of a plane of this form right now. Okay? So we're going to do that with 3x plus 2y plus z equals 6. And this is kind of a special plane. Notice all the coefficients are positive and the 6 is positive. And furthermore, all of these coefficients divide into 6. When that happens, it's really easy to graph the part of the plane that lies in the first octant. Let's call it the first octant. What do you think I mean by the first octant as opposed to the first quadrant? The x, y, and z, I'm going to, just for variety, I'm going to make this guy the positive x, this guy the positive y, so I've rotated it, and this guy the positive z. What do I mean by the first octant? Well, x, y, the x-axis, the y-axis, the z-axis split up space into 8 octants. The first octant would be the octant where all the coordinates are positive. So when you get the special case where a, b, and c, and d are all positive, this is a really easy shortcut for graphing part of the plane in the first octant. Comes in handy. So what you can do is you can graph the intercepts and then just connect the dots. And it'll look like a triangle, a filled-in triangle. So you're only graphing a very small segment of that plane. So like you did back in beginning algebra, let's make a chart. This time it has to have 3 coordinates for each slot in the chart. If I wanted to find the x-intercept, what do you suppose I'd have to plug into y and z? 0. For both of them. Now that we're in space, we've got to plug in, because if you're a point on the x-axis, that's what an x-intercept is, right? The value of both, look at the picture, the value of both y and z are 0. Does that make sense? Okay. And then likewise, if I wanted the y-intercept, I plug in 0 for x and z. If I want the z-intercept, plug in 0 for x and y. Okay, so think about this. What would the x-intercept be? All you got to do is cross these out, because if you plug in 0 for y and z, they're gone, right? You get 3x equals 6. So what's the x-intercept? 2. 2, 0, 0 technically, right? 2, 0, 0. And then what would the y-intercept be? Cover up the x and the z. What do you get? 2y equals 6. So what's the y-intercept? 3. Does everybody see where that 3 is coming from? Is that okay? And what do you get for the z-intercept if x zeroes out and y zeroes out? Just 6. So these are 3 points that you're going to plot and just connect the dots. This is the easiest one to graph of all 3 of them that I've shown you. So let's go out 2, 0. And then on the x, and then let's go out 3 on the y, and then 6 on the z. I don't have to use the same distance between the scales. 1, 2, 3, 4, 5, 6 on the z. And then just connect the dots. And then this can look really nice when you do it in pencil, because you can shade this in, right? There you go. So that's just part of the plane in the first octant, part of the plane, 3x plus 2y plus z equals 6.